In this video, I'm going to go through YTSS Prelim 2022, the practical. This is for question 1. So for question 1, it is the design question. In the design question, the format is that the first few steps, we are trying to use the instruction given here to guide you and give you some hints to what is the independent and dependent variable. So when you first look at this circuit, actually, these two questions should be popping up in your mind. Whenever you're dealing with electrical circuit, you need to ask yourself, can I change the resistance of this circuit? And what component is that is responsible for changing the resistance of the circuit? So if you look at this circuit, you realize that is there any component that will allow you to change its resistance? It has a battery, switch, ammeter, a bunch of resistor over here, fixed resistor, and then a voltmeter. So just by looking at the circuit, you will know that there's no way you can change the resistance. And this means that the power of your heater, is it going to be fixed or it can be adjusted? So I know some of you may be thinking, well, strictly speaking, if I can increase the number of battery, then I can change the power of the heater. But how many electrical experiment that you did that there's instruction to tell you that, okay, first reading you put 1 battery, second reading put 2 battery, third reading you put 3 battery? Very seldom, right? Most of it, the number of battery is fixed from start to the end. So if you look at this circuit, you will realize that actually the power of the heater is fixed as well, right? And this means that the P over here is going to be fixed, and that will help you reduce some of your insecurity in your design experiment, because now you know P is fixed. Okay, then for part A, it is basically to warm you up, and basically is to tell the marker that your battery and your series of resistors are working, because we know what is the correct expected value. So at the same time, it also check whether you remember the precision of your ammeter and your voltmeter by rote memory, or that you remember it as equipment whereby you need to read till half the smallest division. So when you see this statement about reading to the half the smallest, it means that for some ammeter it could be 1 dp, some ammeter could be 2 dp, so on and so forth, depending on its range. So the range that is given to you, the ammeter that is given to you, right, it will have a precision of 2 dp. Okay, if by now you still do not know what is the smallest division and what is meant by half the smallest division, please come and see me, and then I will explain to you nicely. In the next part, you are supposed to multiply the two of them together, and with our simplified precision rule, we will follow the least SF. In this case, it will be 2SF. Unit of power is W. Then after that, you are asked to set up this setup, right? You place the heater into this, and with our earlier discussion, we now know that the power over here is going to be constant, right? Then after that, you are asked to find the mass of the oil, follow least SF again, which is 2SF, so there's that. And then after that, you are asked to observe that how long it will take for the temperature to rise for 2 degrees Celsius. So during the actual practical, I remember that there are some of you who waited too long. Actually, and then after that, you raise your hand and ask me for help. In O-level, actually you don't need to, because it is actually part of your experimental skill. Just think of it as, you know that section A is only 55 minutes and you have 2 questions. So meaning that you should spend about 20 or 30 minutes to solve 1 question. And if the waiting time is more than 10 minutes, that means it is taking up more than 1/3 of your experiment time. You should know that it's not worth the wait and you should carry on, right? Or maybe at the 8-minute mark, if you feel insecure and you really want to know the answer, you can raise your hand and ask the SS already, right? So if there's a question asking you to take down the time taken for a reaction to happen, and it's taking more than 5-8 minutes, you should know that something is wrong and you should ask the examiner. And if the examiner give you a reply like you should everything is alright, it is expected, then maybe you should think of a way to, bypass it or just put the dummy value in first, and then you move on for the rest to complete the rest of your experiment rather than to wait, right? So in this case, you can leave your time in seconds, and for your stopwatch, the precision is now 1 dp. Okay, 1 dp. Okay, then after that is the difficult part, whereby it is the design experiment. So whenever you are given a design experiment, you'll be given a equation, an expression. There are always these 3 questions that you need to ask yourself. Among all these parameters, what are those that will change or can change or will react to a change? Second question is, what are the constants in this case? And the most important question is, what are you trying to find? So if you read the requirement of the experiment, you can see that over here, you are supposed to obtain a constant C, meaning that you want to find this guy. So the thing that you want to find is C, right? And this thing will appear either in the intercept, right, or the gradient. You do not know yet, but you know that it will be there, either at the y equals to m. I'm referring to this. Okay, either it will be at the intercept position, which is here in green, or it will be appearing in the gradient position, which is in yellow, right? Then let's go back to the first 2 questions. What are things that are constant? So earlier we say that if you look at the experiment over here, you can see that in our circuit, there's no way you can change its resistance, meaning that the power of the heater is going to be a constant. So immediately when you look at this equation, you should notice that, oh, okay, my P here is going to be constant, right? I can't change it. So I'm going to put P there. Then now of course, I know that C is something that I want to find, and the question says constant, meaning that for the rest of the parameter T, M, and delta theta could be something that you can change, right? So I know that T can change, M can change, delta theta going to change. So I ask myself, what am I going to change in order for me to have the easiest life, right? If I were to change the amount of oil, I can, and then if I'm going to change this, right, I want this to be my independent variable, then something has to react, right? So I would expect, if this is my independent variable, then maybe this one will be my dependent variable, and then I would move this guy down to the constant part, right? Or if I don't like that, I don't want to change the amount of oil, then what I'm going to do is maybe I will change the amount of temperature rise, right? And then as a reaction, I will check the amount of time taken. So this means that I have to keep my mass of the oil constant. So I will move it to this. So there are actually many ways of doing this. So for me, I don't like to change. For me, what should I say that? For example, if I'm really doing this experiment, the last thing I want to do is to pour away the oil, and then I need to measure a new amount of oil and put it back. So what I'm going to do is that I'm going to keep M constant, right? If I were to do that, then my equation PT equals to MC delta theta. Then what happens is that I will group my MC as a constant. I know that P is also a constant, right? So what I'm going to do is that I'm going to shift them together. So it will form just a chunk of constant, right? Then I don't need to worry about it. Then I need to ask myself, okay, which one is going to be my independent? Well, my independent can be the amount of temperature change, right? So I want like 2-degree change, I go and measure how much time it takes. Then 4-degree change, how much time it will take, so on and so forth. And I want my independent variable to be in my X position, and I want my dependent variable to be in the T position, right? Because that's the norm. So I would always want to follow the norm. So this guy over here, you would try to put the independent variable here, and then you put the dependent variable here, right? So for my case, my dependent variable will be T, and my temperature change is going to be my X. So now with just the preliminary finding, I would know that, okay, what kind of graph okay, so I will answer in this sequence. So things that I want to keep constant, I know I'm going to keep P constant, I'm going to keep M constant. and I just need a pull row. So that's all. So I have done this. Then after that, a statement of graph that I'm going to plot. So in this case, I'm going to plot my this graph, right? T versus delta theta. So I'm going to plot T versus delta theta. So I'm done with this. I'm done with this. Next thing, I need to have an explanation on how the constant C can be obtained. So I know that in my graph, right, after I plot this graph, right, of T versus delta theta, I'm going to get a straight line, and the gradient of this straight line, right, is going to be equate to MC over P. So I know that my gradient over here is going to be equals to MC over P. Well, this means that if I want to find C, it means that it will be P times my gradient divided by M, right? If I just answer these 3 bullet point, I would have gotten 3 out of 5 bullet point, right? Oh, and also I need a table, right? So I need a dummy table over here. So if I need a dummy table, that means okay, what kind of reading I need? So I look at this. I would definitely need, so I need to construct my dummy table. So it means that I will definitely need my delta theta in degrees Celsius. Then after that, the reaction will be the time taken for it to happen. So I will need TS. Anything else? No, I don't need anything else. That's all, right? So my dummy table will be just 2 column. So I have also answer suitable table. So I answer 4 out of 5 bullet point, right? So if I run out of time, I will just document all these things that I have done into my planning. But for the sake of going through, we are going to complete this, right? We are going to do it whole. So independent variable, like I said, we have done it, right? We want temperature change to be my independent variable. I want to give it a symbol as delta theta, and it is measured in degrees Celsius, right? The dependent variable will be the time taken for this temperature change to happen, and I want to give it a symbol as T, and I will measure it in terms of seconds, right? The things that I want to keep constant, well, very easy. The power of heater, right? The mass of oil. You notice that I will always have this statement, something of something, right? It could also be position of my thermometer, right? How far my thermometer is. Yeah. What else? Yeah, that's about it. I just need a few of them, right? So that's it. I have set up it. What are the things that I need, right? So if you look at the answer key, basically we are looking at something that's very, very general, right? But let's say I do not want to go into all this nitty-gritty. I just want to clear as much marks as I can. So I have done this. Now I want to do this. So I will just leave some space over here, and I will construct my dummy table over here. So I write down here my dummy table, right? I will have this, and then I will have this, right? So then I use ruler lah, of course, to do this. Then after that, what do I need? I need to tell, so I'm done this. So now I want to do this, a statement of the graph, right? So I will just say, maybe somewhere below here, I will just plot, my case would be T versus delta theta. I will plot T versus delta theta, right? Then after that, I will say I will find C using C equals to P times gradient over M. So P times gradient over M. Okay, if I'm running out of time, I will just leave my design as it is like that, and I will just move on, right? So for our practice sake, then now I'm going to fill up the most challenging one, which is the detailed explanation. So like I said, these are just the skeleton of the experiment, and now I'm going to fill it up, right? It's actually pretty easy. So first, I need to have measure and record step, right? So I will write down here, measure and record. Wait, before I do that, let's see if I can copy any of these steps. Maybe D is useful, right? Because I want this to happen, right? A change of 2 degrees C, right? And I seems to have forgotten something as well. I need to set up the experiment as well, right? So I write down set up figure 1.2, right? So I will set up figure 1.2. Then after that I need to pour oil inside. So I will do pour 36 gram of oil inside. So I will just write down here pour 36 gram of oil into the beaker. Then after that I will repeat step. What's the step I want, right? Oh, I want to heat it up, right? Step D. So I want to repeat step D, and when I repeat step D, I will measure and record the temperature change as delta theta using thermometer. Right, so when I do this step, measure and record temperature change as delta theta using thermometer, I have cleared the independent variable step of the measure and record, right? I have included using what equipment, right? So after I heat it up, I also need to measure and record the time taken for the temperature rise as T using stopwatch. So once I have that, I will have the measure and record statement for my dependent variable. I've included the symbol and using what equipment. So I have done this, right? Do I have any calculation step? I don't have it. I don't need to calculate anything, right? Because if I look at my equation, as long as I have T and I have delta theta, I can get a graph out. I don't need to calculate anything yet. So I think this step I can skip because I don't have anything to calculate. Then I need to put the data into a table, right? So then I will tabulate delta theta and T, and that will be enough. So I have my tabulation step over here, right? So now I have one set of data, right? So I need to get 5 sets of data. So what I'm going to do is that I'm going to do the repeat step for 4 to 5 times. So I will just write down the keyword repeat. So this is you see, I shouldn't use bullet point 1 2 3 4 5 6 7. So I should repeat step 3 to 5, but with different, or I shouldn't use just with how many different one, with 5 different delta theta, and obtain the corresponding T. You can see that my phrasing, right, is not fixed. The only thing that is fixed is my keyword here. So I repeat step number something something for how many time, and what are the things that I want to change, what are the things that I want to get, right? So I have done my repeat step. Lastly is my plotting step, which is over here, right? Then I have find what. So just by doing this, I will get full mark, right? So that's how you get it. And that's all. So remember to like and subscribe.